Hi guys, so welcome to our channel of Sciences and Mathematics. I'm very much excited. Today we are going to come with a topic in chemistry. So this topic is a basic one that we are going to look at different aspects of matter, but we are going to specifically start with an atom because this is an introductory topic. I guess some of us are also very much eager to know how this concept of chemistry was developed. Of course, there's a lot of history behind it, but for now we shall just start with the basic ones, so that as we continue with some of our proceeding lessons, we're going to develop this, and it's going to give us concepts and ideas on how to solve some of the problems that we may come across in chemistry and specifically physics. It will involve some of the aspects of mathematics. So for that case, we'll be needed to know one or two, but in case of need, we'll have to remind ourselves about some of the maybe the mathematics concepts that may be needed at that time. So without further ado, thank you and welcome. So for that case, it's very interesting to know that during different times in history, man has always aspired to find out what is in his environment. So part of this curiosity has led him to the development of different fields, both in mathematics and sciences, history and philosophy, which we of course come across today. And this gives us an idea in a nutshell that everything has got the history behind it, and there's a sequence of development or steps that were taken in order for us to reach where the aspect of development of each and every discipline that we study in our schools and different colleges up to date. So for that case, we'll look at a small aspect of the history of an atom and try to see how different scientists or individuals or philosophers try to visualize the concept of an atom. So, by its definition, an atom is the basic building block of matter. But let's see how different individuals came to the idea of an atom and what was the definition, their definition of an atom. So for that case, if we look at this term, an atom, it relates to a Greek word atomos, or atomos as we can say, maybe different pronunciations. Atomos, which was actually conceptualized by a Greek philosopher by the name Democritus. Some of the works of different people refer to Democritus as a loving philosopher. I don't know whether he used to laugh, but that is one of his names that was given. So atomos is a Greek word that refers to indivisible. So atomos postulated that there is part of matter which is indivisible. In this sense, he had a concept that matter cannot be divided indefinitely. So which means there is a section of matter, as you continue dividing it up to the infinitesimal level, that cannot be divided any further. So he called that part of matter atomos. So nowadays, this is the derivative. The term atom is a derivative from that term, so that's where it came from. So as time went by, there are different scientists who came up with different concepts. But first of all, we are going to look at the importance of studying this particular topic. So some of us may ask ourselves, oh, okay, I'm learning this concept, of course. How is it going to be applicable in my future life or the society? So for that case, the study of an atom as an idea is very important for us, especially for us who are going to study different subjects, both in chemistry and physics. because it's going to give us an idea on how chemical reactions take place. So it's going to create a fundamental basis for us to understand the chemical reactions. And then number two, it's very important for us to study the concept of an atom, because it's going to give us the concept about the existence of matter, how matter came to existence. So for that case, that is existence of matter. And then we are going to find out that by studying about an atom, it's going to give us a concept of how energy is generated. We have different forms of energy, but specifically here, maybe we are going to mention about atomic energy. Atomic energy. Of course, it is part of one of the green energies that we are talking about, which is does not cause a negative effect on the environment. So atomic energy is very important. It assists us in running our day-to-day life. It's a clean form of energy. And then by studying an atom, we are going to see how different molecules combine in order to form pharmaceutical products. And even how different concepts of combination of these atoms are being exploited in the food and processing industry, which is very essential for our survival. So food processing industry. So in a nutshell, the importance of studying this particular topic is going to assist us on how to explain how different chemical reactions take place. And then number two, we are going to see that it's going to give us an idea on how different forms of matter do exist in nature. And then we are going to find out that by exploiting different aspects of this atomic concept, we are going to come up with the concept of atomic energy, which is already in operation in our day-to-day lives. And it's going to show us that this is very important, because atomic energy assists us to run our day-to-day lives in different ways, maybe in form of processing machinery and all that. And then pharmaceuticals industries, this is a combination of molecules. Of course, further we are going to learn about some aspects of organic chemistry and the mechanisms, so which means the pharmaceutical industry is exploiting this concept of an atom to know how, by understanding an atom, one is able to come up with different molecules, some of them which have pharmaceutical properties. And then food processing industries, you find that some food processing industries may require preservatives, some may require to come up with different recipes, which of course made flavor in our food. So it's very important for us to understand on how we can combine different aspects, or use the knowledge of an atom in order to come up with those products. So in that case, we are going to look also at the different theories that were postulated by some individuals, and how some of the ideas that preceded were discarded, maybe due to the evidence that came about. Some were discarded and some were maintained. So in that case, you will find out that the current definition of an atom and some of its constituents that we are going to see further is a result or a culmination of different experiments that have been performed throughout history. So for that case, we have looked at in a nutshell, a small or a little amount of history, a short history of an atom, and we have mentioned this individual that we say that came up with the concept of an atom and said that the indivisible part of matter is known as atomos. That's Democritus. Now for that case, we are going to see that after this concept, how some of the scientists came about and discussed Democritus' concept, and found further through experiments that there existed smaller portions or parts of matter that were even smaller than the atom. Actually, these particles, or as we can say, or we can call them. So you see now we have talked about an atom. And we said it's as the smallest block of matter. Later we are going to see that this is a part of matter that makes what we call an element. that consists of similar atoms which have the same chemical and physical properties. So for that case, we are going to look at what we call subatomic particles. Subatomic particles. So I've mentioned that after Democritus came up with this atomos concept, which refers to as indivisible part of matter, some scientists came about trying to find whether these atoms really consisted of other smaller units, which of course were verified. So, so fast forward, after Democritus, Democritus concept, which was around developed between 430 BC and 400 BC. It took almost 2,000 years for other scientists to come and try to revive his work and find out exactly what he was trying to refer to. This basically was due to the fact that maybe there were some beliefs which were being held, which people did not readily question. Or number two, maybe they were not interested in trying to find out. Or number four, you can find that better equipment were developed, which assisted in finding out new evidence that maybe the atomos or the indivisible part of matter really existed, or maybe other new parts of this matter came about. So for that case, there's an English scientist by the name John Dalton. John Dalton came up with the idea that elements are made up of tiny particles called atoms. So in this case, we see that he is also trying to stress on Democritus concept. And also he said that atoms of an element are identical, but they differ from those of other elements. So we are going to see also, when we are going to learn about the periodic table, that we have a range of elements which display different properties. But in this case, as you move from one element to another, you'll find that each element is made up of atoms, which are similar, of course. They display similar properties. But when we compare one element and another, you'll find that atoms of one element differ from that one of another. So that is what John Dalton came about with. And then he came up with the concept of conservation of atoms. And he stated that whenever a chemical reaction takes place, so in this case, John Dalton said that he reinforced the concept of atomos, that elements are indeed made up of atoms. And number two, he said that each element consists of similar atoms, but which are different from atoms of other elements. For instance, if I say this is element X and element Y, then you will find that atoms of element X are the same, but they are different from atoms of element X. So that is what John Dalton postulated. And then different atoms form compounds in constant ratios. We are going to look at this when we are going to look at the mole concept. So for that case, we are going to look at that in chemical reactions, there's also the law of conservation of matter, which of course John Dalton also infused in part of this theory that we are referring to as now Dalton's atomic theory. So for that case, John Dalton had that concept. So in summary, he said that elements are made of thin particles known as atoms, and atoms of an element are identical but differ from atoms of another element. And he said that there's a conservation of atoms whereby in a chemical reaction, the atoms will always be maintained. Whatever that will only be happening is the rearrangement of the atoms, but the number of atoms will always be maintained, hence conforming to the law of conservation of matter. And then he stated that different atoms form compounds in constant ratios, which I've said that we are going to look at this particular aspect under the topic of the mole concept. So apart from Democritus and John Dalton, there are other individuals who came up with the ideas which supported the concept of an atom. And one of these individual is known as Michael Faraday. Michael Faraday did an extensive work on electricity, which we're going to look under the topic of electricity. But for now, let's confine ourselves to an atom. So he was an English chemist, and we also postulated that the structure of atom is somehow related to electricity. So this is Michael Faraday's argument. That the structure of an atom is somehow related to electricity. Of course, we are going to see the relationship after we have gone through some specific topic which supports, of course, this concept, and developed new ideas. We're going to see on how the interaction between subatomic particles and the concept of electricity come about. So that was Michael Faraday's argument. And then you find that after the atom and the concept of an atom had been developed, John J.J. Thomson came up with the idea that atoms have negative particles. So this is J.J. Thomson. So he came up with the idea that atoms consist or are made up of negatively charged particles. Through an experiment using the cathode ray tube. Of course, we're going to make a small demonstration about what this cathode ray tube is. So for that case, John Dalton did this one by using an experiment, and he actually, through some of his work, developed an idea that these negatively charged particles, an individual negatively charged particles consist of a charge of 1.6 times 10 raised to the power 19 coulombs. Charge is measured in coulombs. So that was John Dalton's argument, and they measured the mass to charge ratio of this particular negative charges that he referred to. So in summary, John J.J. Thomson's argument was that atoms consist of negatively charged particles, and its experiment was backed by the fact that he had done an experiment using the cathode ray tube. Now, a cathode ray tube is a tube that consists of a vacuum, whereby a beam of rays, these are incident rays that are coming inside the vacuum. This is an evaporated cylinder. You will find that there are also charged plates here, could be metallic plates. Charged to it means one of them consists of a surface consists of positive charges, while another one consists of negative charges. So when John Dalton passed a beam or a ray of so this array incident, when he passed it through the field of electricity, it's an electric field, he found that this one was deflected towards the positive, or what we call the anode, and this is the cathode. So from this, from the law of attraction, we know that like charges repel one another, while unlike charges attract one another. So from this perception, we can see that if indeed he was able to observe that the beam was deflected towards the anode,
So definitely the charges that were contained in that particular beam must have been negative charges. So he concluded that atoms indeed in this particular case consisted of negatively charged particles that he called electrons. So we can see that from the concept of atomos, and then Michael Faraday and John Dalton, J.J. Thomson had a different concept, and he came up with a scientific method of trying to find out evidence about the properties of an atom by conducting an experiment using a cathode ray tube. So he came up with a model. A model is a visual representation of an object, a person, or maybe it can be an object, a person, or a visual representation of something like an object or a person, as I can say, and other things, of course. So this is a visual representation. So in this case, J.J. Thomson came up with a visual representation of an atom, or the way he visualized an atom to be. And this model is known as the Plum-Pudding model. The Plum-Pudding model. Now, the Plum-Pudding model suggested that electrons are dispersed in a uniform positive charge. So which means if this is an atom, and charges, the positive charges are distributed in a uniform positive charge. Electrons are dispersed in a uniform positive charge, which means the charges are distributed evenly, whereby we have an aspect of positive and negative electron. So this is the first model that we have come across. As we proceed with our topic, we're going to see how different models were achieved by maybe trying to find out that maybe the preceding scientists who had come up with this idea had not maybe, or there's an idea that they had overlooked or were not able to conduct an experiment to verify. So when new ideas came, or maybe methods came, some of these ideas of earlier scientists were discarded and new ones were promoted. So for that case, that is J.J. Thomson's concept. So in this case, when we say that J.J. Thomson came up with the idea of trying to calculate the charge and the charge to mass ratio, which of course he found a figure. Other scientists indeed came up with the idea of trying to find out whether the charges that were proposed, the charge that was proposed by J.J. Thomson holds. So for that case, there was this American physicist by the name Robert Milken, who did an experiment to measure the average charge of an electron using an oil droplet. So he also found out that the electric charge is 1.60, the figure that we have written, and each electron had a mass of 9.11 times 10 raised to power negative 28 grams. So for that case, you can find that it is a unique concept which these two scientists, that is J.J. Thomson and Robert Milken, came up with by employing scientific methods, which are experiments, in trying to back up their arguments. So for that case, Robert Milken also came up with the idea that, so this one, he actually did an experiment to verify that the charge of an electron is basically 1.6. So this one, he measured charge to be 1.6 times 10 raised to power negative 19 coulombs. This is a charge of an electron charge. And then he measured the mass of an electron to be 9.11 times 10 raised to the power negative 28 grams. So this is a very small amount of mass, as we know from the ones that we basically use for the dimension of mass. So from this particular concept, we're going to see that other following scientists also employed different experiments. We have seen that there has been already a discovery of a negative charged particle in an atom that we have referred to as an electron, and that one was done by J.J. Thomson, and then who came up with the Planck pudding model. And Robert Millikan did an experiment also to affirm that the charge of an electron is 1.6 times 10 raised to the power negative 19 coulombs, which is given by letter E, small e, and the mass came up with a figure for mass using oil drop experiments. Now, these particular concepts that we have been seeing which have been developed, maybe we are going to see that as time goes by, do they hold, or other experiments came and discarded the arguments. So in this particular point in history, there are also experiments which were performed different from an atom, or tried to verify the existence or discard the existence of an atom in different parts of the world. We are going to see how, as we say, different disciplines are related to physics, but borrowing of these concepts are not uncommon. So for that case, there was a scientist by the name Maria Curie, and her husband, her spouse. They conducted different experiments on a topic that we're going to look later. Of course, this is the topic of radioactivity, and this also is going to stem from the concept of an atom, but we're going to look at it later. I mentioned that intentionally because during that time they used to collaborate with some of these scientists that we are mentioning, or we are going to mention, in order to assist them borrow the idea or try to develop some of their experiments. One of these scientists was known as Ernest Rutherford. So for that case, Ernest Rutherford conducted a number of experiments on alpha particles. Alpha particles or alpha rays fall under the topic of radioactivity. That's why I actually had to mention this particular scientist, because there was a collaboration between this particular scientist during that time. So in that case, Ernest Rutherford was conducting experiments on alpha particles, and he postulated that the positive charge is not like a pudding, but concentrated in the nucleus, as shown in the gold foil experiment. So for that case, Ernest Rutherford, I'm going to just draw a sketch. Maybe you will just pardon my drawing, but I'm going to explain and demonstrate on how this particular concept was developed. So for that case, this was a gold foil. Of course, like this. Look at it like a 3D. So for that case, let's say this is an alpha source. An alpha source meaning that this particular source is generating alpha particles, which are of course being emitted in this direction. And this is a gold foil. Foil is a very thin kind of a substance, or a sheet of metal. It can be metallic paper, but for this case, this is a gold foil. So this, of course, they were confined in a lead block to avoid exposure during handling. So for that case, that was a precautionary measure in order to avoid exposure, because later on we're going to see that the alpha particles were found to affect the body tissues. So for that case, when the alpha particles are directed to this point, you'll find that some of them are deflected. So this one's reach here, some will pass through, some will be deflected this way, some will bounce back. So in this case, when this kind of an outcome is achieved, you will find that, of course, the alpha particles are positively charged. They have a positive charge. So you'll find that the rays which are, let's say maybe this is A, B, C. The one that bounces off indicates that there is an object here. Maybe it has hit the object at an angle and deviated away. So this one deviated. This one bounced back. It's also an evidence that maybe there was a head-on, or maybe hitting the object but at a different angle from this. And this one shows that there was an empty space, or maybe the ray did not come across an object to hit on, so it just went through. So for that case, using this one, Ernest Rutherford observed that most of the atoms, or an atom, most of its part is made up of an empty space, and therefore the particles that were being deflected were positive charges, which he named protons. So this confirmation that when most of the rays are passing through this indicates that most of the part of an atom, or just the physical aspect of an atom, a large part of it, or a large percentage, is made up of an empty space. And the deflected rays, which are positively charged, shows that an atom consists of positive charges, which of course Rutherford named to be protons. And later there was an experiment that was conducted around 10 years later by Ernest Rutherford and James Chadwick, in order to describe the presence of what we call the neutron in an atom. So we have seen that J.J. Thomson conducted an experiment to confirm that there's a presence of what we call negative charges, which he referred to as electrons. So Ernest Rutherford has confirmed the presence of positive charges inside an atom, which he has named the protons. And now there was another scientist who said that each element contains a unique number of protons, which of course we are going to learn under the topic of atomic masses and the molar masses, about the atomic number and the mass number. So for that case, Henry Moseley postulated that each element contains a unique number of protons. Now, in that case, we can see that the concept of an atom has been developed. Some of the ideas have been held, and there are some experiments which have been performed. So in summary, we can see that from the time of Democritus, who said that matter is made up of very small indivisible particles, which are known as atomos. It's a single particle known as an atomos. And later on, there was an experiment that was conducted by John Dalton. John Dalton came up with a concept that matter is also made up of particles which are called atoms. and they postulated that atoms as an element are similar. So atoms of an element are similar. And they said that atoms of one element are different from atoms of other elements. And we also said that during a chemical reaction, there is what we call the law of conservation of mass, whereby it said that during a reaction, it's only the rearrangement of atoms that occur, but no atoms are gained or lost in that process, the formation of maybe different compounds during a chemical reaction. So the law of conservation of matter. And then later on we saw that Michael Faraday stated that electricity, that an atom somehow related to electricity. So this is Michael Faraday. And then, so he related atoms with electricity. My handwriting is okay. I hope it's legible. So atoms are related to electricity. And now the performance or conducting of an experiment by J.J. Thomson led to the discovery of electrons, and they came up with what we call the plum pudding model. Plum pudding model of an atom. J.J. Thomson also was able to perform an experiment that determined the charge of an electron using a cathode ray tube. So he came up with the plum pudding model, and they suggested that electrons are dispersed in a uniform positive charge. Robert Milken measured the charge of an electron using an oil droplet, and they also affirmed that the charge of an electron is equals to 1.6 times 10 raised to power negative 19 coulombs, and also measured its mass to be 9.11 times 10 raised to power negative 1 kilograms. So we have also seen the work of Ernest Rutherford, who came up with the concept of protons, which are positively charged by using alpha particles. He conducted an experiment. I've shown you an experiment of alpha particles with the gold foil. So he came up with the concept of protons. And Ernest and Chadwick conducted an experiment together to confirm, Ernest Rutherford conducted an experiment with Chadwick to confirm the presence of a neutron inside an atom. So this is Rutherford and Chadwick conducted an experiment to confirm the presence of a neutron. Of course, we are going to see that this is a particle inside an atom which has got no charge. So for this case, we have seen that there has been a number of steps which have been performed, or there is some advancements which have been attained. First, by the discovery of an atom. Second, by discovering some of the different parts of an atom which we have called the electron, proton, and neutron. We have also looked at the plum pudding model that was suggested by J.J. Thomson. So we are going to see the last concept about the atom, which was developed, of course, which of course to date is very much applicable, and it's being used in different fields in order to describe some aspects of nature, or through experiments we are able to explain how different aspects of nature. Remember, one of the objectives that we stated in this particular topic was the atomic concept is using to explain the existence or behavior of nature. So we are going to look at the last two scientists who came up with the concept that we're using today. And this is the concept that is being used in modern physics, both in physics and chemistry. Actually, it's a wider part of physical science, which we're going to see in some of the topics later. So this scientist was Niels Bohr. Niels Bohr. I don't know whether that's the correct pronunciation. So this was a Danish physicist who came up with a concept that after the discovery of the electrons, the protons, the neutrons, he said that electrons orbit sorry for that. He said that electrons orbit the nucleus. So for this case, there was evidence which was suggesting that the nucleus is centrally placed in an atom. So this concept led to Niels Bohr concluding that electrons orbit the nucleus, and this was the idea that led to the development of the model based on hydrogen atom, which of course we are going to see later. And they postulated, so Bohr's argument was that electrons orbit the nucleus. The nucleus is the center that is here that consists of protons and neutrons. So for that case, the protons and neutrons make the nucleus, while he said that the electrons revolve or orbit around the nucleus. So Niels Bohr also said that energy of electrons, so we are going to see the development of another concept, energy of electrons. Or energy of an electron is quantized. This is quantized. This should be visible. Energy of an electron is quantized. We're going to see the concept of quantization of energy later, but this led to the development of a new topic in physics and chemistry that we call quantum physics or quantum chemistry or quantum mechanics in that case. We're going to see the motion of those particular subatomic particles. So there was a development of this particular model that we call the wave mechanical model. Wave mechanical model of an electron. So apart from us trying to see how an atom appears, sort of visualize how an atom appears like according to different scientists, there's also an aspect of trying to find out or try to discover how an electron exactly is or how it behaves. So this led to the development of the wave mechanical model, which tried to find out the properties of electrons and postulated that electrons act like particles and waves just like light. So this in a nutshell is a concept trying to suggest, of course, the topic which I said of quantum mechanics. And we're going to see later that actually electrons, as they are being referred to as particles, they display some aspects which of course are going to give them a different characteristics, which they are being referred to as waves as well. So for that case, there are different experiments which were performed to back up this wave mechanical model that was suggested by Niels Bohr, and perhaps some of his students and other scientists like Louis de Broglie. They came up with a mathematical equation to describe this concept of the wave mechanical model, which are heavily applied in quantum mechanics, which we're going to look at later. So for that case, the discovery or the arguments of Niels Bohr and Louis de Broglie form the basis for quantum mechanics, which describes the motion of subatomic particles or small particles like atoms and molecules, which we are going to see later. So for this case, there are different experiments which I've said which back up the ideas, and we're going to look at how various experiments maybe were conducted to support an idea that we have mentioned in one case or two. This included like the Gamma and Davidson experiment that were performed to support the wave mechanical model, and also others which we are going to mention as I have said. So for that case, I hope that we have learned a concept or two about an atom, and we're going to come up also with different aspects as we go by, or try to revisit the ones that we have not understood. So for that case, thank you very much. I hope the lesson was enjoyable, and we're going to make others more interesting. I'd like us to engage in the comment section and try to come up maybe with a problem or two if we have one, so that we can solve it as a group. So for that case, thank you. God bless you. Bye.